This is Unit 7, Lesson 1, Scatterplot and Line of Fit. A scatterplot is a graph of points with one variable plotted on each axis. And what we want to be able to do is we want to be able to describe that scatterplot. We describe a scatterplot in two ways. One, by describing what kind of correlation it has, and then by describing how strong that correlation is. The correlation is the direction of the relationship between the two variables. A positive correlation, and this is an example of what a positive correlation looks like. A positive correlation is one in which both variables increase. And you could use the example of as temperatures rise, so as the temperature went up on the y-axis, ice cream sales might increase in a town. A negative correlation is when one variable increases and one variable decreases. Our first example problem that we're going to work is an example of a negative correlation as the latitude of the cities we look at rises, the average annual temperature of those cities drops as we go. And then the last one is no correlation, meaning there's really no discernible pattern. We really can't tell if those points have any kind of relationship to one another. Correlations are great at just kind of giving you an idea of the relationship between information, but you can't say that one piece of information causes the other one to happen. So we will never try to determine if one of them caused the other one. We'll just describe the relationship that they have with one another. We will be using, to write the functions of these, we'll be using the correlation coefficient, which is represented by the letter R. And that's simply a number that describes how strong that relationship is. So a correlation coefficient that's really close to +1 or really close to -1 is a very strong relationship. And the weaker the correlation is, the closer to 0 that correlation coefficient will be. So if we see a strong negative correlation, the graph goes down as we go left to right across, and the points are all very close together. A strong positive correlation goes up as we go across the graph from left to right, and the points are still very close together. For weak correlations, they're still going to go down left to right for negative and up left to right for a positive, but the points are just going to be scattered out a little more. They're not going to be real close together. And we're going to take that and we're going to try and find what's called a line of fit or a line of best fit. Depends on what you're reading, on what it's called. And that just gives us a way to write a function so that we can make predictions or estimates about where other points on the graph might lie. So our first example was the table that shows the latitude and average annual temperature of cities around the world. The graph points on the given graph, and I will give you a graph in your notes. And we're going to graph those points. My points are already graphed. Those aren't my points. Where'd my points go? These are my points. I've got the points already graphed, so I've got all of the cities already graphed here. Let's talk about how you draw that line of best fit, because you kind of want to draw the line. Makes it a little bit easier sometimes to see how strong or how weak a relationship is. It also makes it a little easier to see what direction it's going if you're not real clear on that. So a line of best fit is simply taking a ruler or a straight edge of some point, take the edge of a book, and draw a line that gets really close to as many points on your graph as possible. Now, you might have some of your points that kind of land on that line of best fit. This is all kind of a little bit whimsical. It's kind of up to you. Where do you want to start? Maybe you want to put the line on Moscow, and you just want to kind of rotate your ruler until it gets kind of close to a lot of the points. So, let's try that and let's see what that looks like. So, that's another line. It actually goes through Moscow, and it still gets fairly close to several of the cities. But the idea here is to just get a line that kind of gets real close. It doesn't have to be perfect. Just gives us an idea of where that graph is going. Our second example was the same kind of idea. And our second example did altitude and boiling point, which was also a negative correlation. And we want to describe this correlation. When I ask you to describe a correlation, I don't need a paragraph. I don't need anything more than a sentence or two. This correlation can easily be described as a strong correlation. The points are close to the line. They're close together. And it's a negative correlation because it goes down as it goes across the graph. So this would be a strong negative correlation. And then just a statement describing what the variables are and what their relationship is to one another, what they're doing as they go across the graph. So in this graph, you would say, as the altitude rises, the average boiling point of water decreases. Or you could say, as the average boiling point of water decreases, the altitude of the cities increases. I'm not picky about which one you describe first. Just tell me how those two variables are related to one another when I ask for a description of the graph. The second thing you need to be able to do in this lesson is you need to be able to write a function and use it to make predictions and estimates about other points on the graph. So we're going to go back to that first table. And in that first table, we had the latitudes and the average annual temperature. And we're going to write the function for the line. So we drew all those different lines. The calculator will actually generate a line of best fit itself. So instead of us having to all draw different lines and use different points to try and make our own function, we're all going to end up with the same exact function because we're going to use the calculator and we're going to let the calculator do all of the heavy lifting. So the first thing you're going to want to do once you get your calculator turned on is I want you to reset your calculator. Remember that second plus sign. And we choose number 7 for reset, number 2 for defaults, and number 2 for reset. So that should have cleared everything out. Did not. Sorry, picked the wrong thing. It's second memory 7. Reset all the RAM, and then we reset. All right, the RAM is cleared out. So make sure your RAM is cleared out. Don't trust other people in your classes. You never know what kind of crazy stuff they've done to your calculator. So what we want to do is we want to follow this list of steps to put everything in our calculator and let the calculator generate the numbers we need to write our function. So now that we've cleared all of that out, we're going to press the Stat button, and the Stat button's right underneath the Delete button. And we're going to choose number 1, because number 1 is Edit, and it's going to let us edit some lists. Let me zoom in a little bit, see if I can clear that up a little for you. There we go, that's a little clearer. So we're going to use this graph right here, this table that we had, and we're going to put this information in, and we want to put the latitudes in L1, so 13.7, and if you'll just hit enter after every number, it will go to the next line. And I strongly suggest you do all of one column and then all of the other column rather than jumping back and forth. And then we'll go over to list 2, and in list 2, we're going to put all of the temperatures that go with each city. The biggest concern that you should have is making sure that you get all of the information in there and that you get it lined up correctly. So we had 8 pieces of information in the first list. We have 8 pieces of information in the second list. We ended at 49.2. We ended at 49.6. Everything is in the list correctly. So we've created these 2 lists. Now we need to tell the calculator to take these 2 lists and generate a line of best fit and the numbers we need for our function. So we're going to hit Stat again. And this time we're going to arrow over to Calculate. And we're going to arrow down and we're going to choose number 8, which is line of regression, which is also another term you might see used in different texts for line of best fit. And we're going to choose the line of regression. Our X list is our L1, our Y's are our L2. We don't have a frequency list. We just want to calculate. So let's hit enter until we're on calculate, and then calculator does a little bit of flashing and we get some numbers here. Now, something you need to realize that I don't know why TI did this. It's going to be in slope-intercept form, which you're used to seeing as y equals mx plus b. And for some reason, TI decided to use A and B instead of M and B. And they decided to do it kind of backwards, and they put the y-intercept as A, and they put it first. And then they put the slope and the x. But what you need is the A and the B, and you need to remember that they were nice enough to give you this so they can tell you, hey, this is how this is supposed to look. We're going to write it as if it was in slope-intercept form. So we're going to take those numbers. We're going to say y equals mx plus b. Remember, this is backwards. So A is our y-intercept. And we're going to round to the nearest tenth just because if we don't, these numbers can get really long. So we're going to go 99.6. And our slope is negative 1. Because that's a 0, I am going to go ahead and round to the nearest hundredth. That way I get a more accurate line of best fit. So my line of best fit for this table right here, my line of best fit has a slope-intercept form, or as a function is negative 1.01x plus 99.6. So this little function, and you could write it as f of x, you can write it as y equals. I'm not real picky about that, as long as I realize, and you have clearly labeled it as your function for your line of best fit. So then the example asks you to estimate what the average, or predict what the average annual temperature for Londrina, Brazil would be. And Londrina has a latitude of 23.3 degrees south. All you need to do is now use that function that you just created to calculate what the average annual temperature in Londrina would be. So we're going to take that negative 1.01, and everywhere there's an x, we're going to replace it with 23.3 because that's the latitude of Londrina, and then negative 1.01 times 23.3. You can do this one piece at a time by following order of operations, or you can just put all of this in your calculator at once, which is what I suggest that you do, because there's no reason to make your life more difficult. And then negative 22.533 plus 99.6 gives us an average annual temperature of 77.067. If we round that to the nearest tenth, 77.1 degrees. Now, if you go back and look at the notes, you're going to see that in the notes, I didn't round the function as much as I did when I did it for the video. And because I didn't round as much, I actually got slightly different numbers. Your rounding is really important, so you need to make sure that you read your directions and you know where to round to. I rounded to the nearest tenth as I went here. Here, I waited until I got to the very end to round to the nearest tenth. Because in the directions back here for writing that function, it told me to round to the nearest thousandth. So when I wrote this function, I rounded to the nearest thousandth. I want my original function to be as detailed and correct as possible. So I rounded out a little further. And then at the end, I went ahead and rounded to the nearest tenth. Make sure that you read the directions for every problem so that you know where to round. Sometimes you'll start rounding way up here as you're writing the function. Sometimes you won't start rounding down to whole numbers or really close to whole numbers until the very end. So let's look at example 4. Example 4 is looking at years after trees have been planted and how tall those trees are. We want to use the same steps from example 3 to generate a line of best fit. Now that's actually already done in the notes, so that's not new, but I want to walk you through each one of those steps. And because the original directions tell me to round to the nearest thousand, this is rounded to the nearest thousand. For the video, I want to just round to the nearest hundredth, and let's see what kind of change that makes in our function and in our final answer. So let's go back to our calculator. We go back to stat and we choose number 1. Now everything is still in there from our first graph. So we need to clear that out. Now you can clear those things out one at a time by hitting clear highlighting things and hitting clear, maybe. Fastest way to do this, go up to L2, hit clear, and then hit enter. Go over, highlight L1, hit clear, and then hit enter. Don't take up any more time than necessary. So our first column in our chart is the years. So the first year was year 0. That would be the year that it was planted. And then the year after, this one was a whole lot faster to type in. And you can use the arrows or you can use the enter button. So we've got 6 years of growth there, the year that we were planted, and 5 years later. And then our heights were 2.1 feet, 4.3 feet, 5 feet, 7.3, 8.1, and 10.2. So now that we've got everything in there, we want to hit stat again. We want to go over to calculate. We want to generate a line of regression, a line of best fit. So we're going to choose number 8. List 1 is our X's. List 2 is our Y's. We're going to hit enter until we get to calculate, and then we're going to tell the calculator to calculate all of that. All right, so for the video, we want to just round to the nearest hundredths place. So we're going to get a slightly different function. So this is the original function from the notes. The function that we're going to do this time, remember, these numbers are backwards. We want the b number first because we want to do mx plus b. mx plus b. We want slope-intercept form. So the m, which in this calculator is the b, rounded to the nearest hundredth is 1.55x plus, and our y-intercept rounded to the nearest hundredth, oh, there's a good one. That 5 rounds that 9 up to another one, which rounds that 2 up. So that's going to become 2.3. This is a much more exact number. And so I would rather you round to the nearest thousandth, but read your directions. Your directions are going to tell you exactly where to round to. So the question is, to the nearest tenth, how tall will the tree be after 10 years after the planting? So we're going to take that function that we just wrote, and we're going to plug in where the x is at. We're going to plug in a 10. And then I'm just going to go into my calculator and I'm going to put that in exactly like I have it written on my paper. And the tree will be somewhere around 17.8 feet. Is this in feet? Yeah. Feet tall. Which actually, rounding to the nearest hundredth, didn't make a big difference this time, not like it did with the temperatures.